everyone, welcome to PULLAS Academy. This is physics class for ECET students by Kiran Kumar Adarpu. Today we are going to discuss about part 6 video in units and dimensions. Here we will discuss about the applications and limitations of dimensional analysis. Today topic is applications and limitations of dimensional analysis. Okay, now so before this topic, first we will discuss about the principle of homogeneity. Okay, now if you know this principle of homogeneity, then by application of principle of homogeneity, then only understood the applications of dimensional analysis. That's why first we will discuss about the principle of homogeneity. Okay, now let us discuss about the principle of homogeneity. Okay, now so what is this principle here? Actually, first we need to understand the statement. According to the principle of homogeneity, so the physical quantities have same dimensions, they can be added, they can be subtracted, and they can be equated. Otherwise, it is not possible to added, subtracted, and equated. That is explained by the principle of homogeneity. That means according to the principle, the physical quantities of same dimensions can be added, subtracted, and equated. This is a statement of principle of homogeneity. Okay, what is the statement? So the physical quantities of same dimensions can be added, subtracted, and equated. Okay, so otherwise it is not possible. So here we have different dimensions. The physical quantities of different dimensions cannot be added, subtracted, and equated. If they have same dimension, they can possible to added, subtracted, and equated. That is explained by principle of homogeneity. That's the importance of principle of homogeneity. Okay, now so now I want to explain one example. From the example, very easily understood what is principle of homogeneity. Okay, now, for example, given this equation, what is the given equation? X is equal to y plus z is the given equation. Suppose this given equation is, so this equation is dimensionally correct. Suppose this is dimensionally correct. So when it is dimensionally correct, so it obeys the principle of homogeneity. So what is the statement here? The physical quantities of same dimensions, they can be added and subtracted and equated. So that means here added these two quantities and equated. Okay, now so then it is dimensionally correct equation is given. This equation is dimensionally correct means what? So x, y, z have same dimensions. It is correct. Dimensionally correct, otherwise it is wrong. That means you have to understand if this given equation is dimensionally correct, what you understood? The dimensional formula of x is equal dimensional formula of y is equal dimensional formula of z. Okay, now so that means the dimensions of x, y, z is similar. That's why here possible to add it, possible to equate it. So if the given equation dimensionally correct, then what you understood? These each and every factor in the equation have same dimensions, same dimensional formula, same dimensions. So that's why you have to understood this. In this equation is dimensionally correct, we have to understood the dimensional formula of x, the dimensional formula of y, the dimensional formula of z is same. This is about principle of homogeneity. I hope you understood. Okay, now this is called as principle of homogeneity. Okay, let us discuss about the applications of dimensional analysis. What are the applications? Applications means uses of dimensional analysis, uses of dimensional methods, uses of dimensional formulas. Don't confuse it. So here these are the important uses. Okay, what are the uses of dimensional analysis? The first application is to check the correctness of the given equation. Okay, now one equation is giving that is dimensionally correct or dimensionally is not correct, that is understood by dimensional analysis. Okay, any equation is given, so that is correct or not, dimensionally it is correct or not, how to understood by dimensional analysis. That is one of the application of dimensional analysis. how to understand the given equation is correct and not. So that is also based on the principle of homogeneity. By application of principle of homogeneity, that given equation dimensionally correct or not, we will discuss clearly. So after that, the second application is to derive the relation among the physical quantity. Not only to check the correctness of the given equation, if you don't know the relation among different physical quantities, so that's also possible to construct by using dimensional analysis. You don't know the relation among different quantities, by using dimensional analysis it is possible to derive the equation. Okay, now that means here by application of dimensional analysis you get the relation among different physical quantities. That's also one more application of dimensional analysis. Okay, we will discuss with one example clearly. Next, one more application is to convert one system of units into another system of units. So one more application is for to convert one system of units into another system of units. So actually that means if you know the one system of units of one physical quantity, if you want to conversion into another system of units, that is very easily possible. If you know the by using dimension analysis, very easily conversion from one system of units into another system of units. That's the important. These all are the applications of dimensional analysis. One more, these are the important applications. One more application, if you don't know the units of a given physical quantity, that is also possible to construct the units of the given quantity by application of dimensional analysis. Already in the previous classes we have derived the units by using dimensional formula. For example, dimensional formula force is mLt power minus 2. So based on that dimensional formula, m stands mass, L stands length, T stands time. That's why the units of force is kilogram meter second inverse square. So based on the dimensional formula you have to construct the units. That's also one of the point. By using dimensional analysis we have to derive one new system of units also. If you want to introduce any new system of units, that is also possible by using dimensional analysis. So these all are the applications, but mainly three important applications we have. One is to check the correctness of the given equation. Second one is to deduce or to derive the relation among the different physical quantities. One more is to convert one system of units into another system of units. Suppose if you know the SI unit, you want CGS unit, you don't know the relation. Already I given some important conversation. If you don't know, that's also possible. If you know this dimension analysis, it is possible to conversion. Okay, now we will discuss clearly about these all three applications. Okay, now based on these three applications in the previous exams, different questions are here repeated. So here repeated area, this is also one more expected topic in this lesson. That's why here also you have to concentrate. Okay. Okay, now we are going to discuss about the first application. I want to explain about this application with one example, then very easily understood. That's why I want to explain this application with one example. Okay, now so listen to me. So here in this application, so for example I have one expression, one formula. So that is V is equal to U plus AT. This is a given expression, this is a given equation. So this is dimensionally correct or not? How can we understood? So here equate and addition. So then if here using equate and addition symbol, then what you understood? So here the dimensional formula V, dimensional formula of U, dimensional formula of AT is similar, then that is dimensionally correct. Okay, how can we understood? By application of principle of homogeneity. Based on the principle of homogeneity, the dimensional formula of V, dimensional formula of U, dimensional formula of AT is similar, then it is dimensionally correct. This is the procedure to check the correctness of the given equation. Very simple. From this example, very easily understood what is the application of dimensional analysis. Okay, for example, so here we have to construct the dimensional formula. Now check the correctness of the given equation in this way. Okay, now first write the dimensional formula of V in the given equation. The first physical quantity is V. V stands for final velocity. So that means it is nothing but velocity. That means dimensional formula of velocity is LT inverse. This is a non-dimensional formula. Write it. Next in the equation, the second physical quantity is what? U. That is dimension formula of U. U stands for initial velocity. Nothing but velocity. Any form of energy have same dimensions. That's why don't confuse here also. Instead of initial velocity, write the same dimension. That is LT inverse. Next in the same way, dimensional formula of AT. What is dimensional formula of AT? Dimensional formula of AT is equal to, first substitute the dimensional formula of A and T in the equation. A stands acceleration, T stands time. Dimensional formula of acceleration is LT inverse square and dimensional formula of time is T. So then LT inverse square into T. So then finally, so L T power minus 1, T power 1, this is T power minus 2 plus 1 is minus 1. That's why finally you get LT inverse. That means dimensional formula of V is LT inverse, dimensional formula of U is LT inverse, dimensional formula of AT is LT inverse. Okay, now these all are similar. That's why what is proved here? Here, principle of homogeneity is proved. Okay, now here obeyed. So that means it is the given equation is correct. That means finally understood. So the given equation dimensionally correct. Given equation is dimensionally correct. Okay, now so this is the procedure, dimensionally correct. Okay, now in the same way, not only here, if you given this example, for example, S is equal to ut plus half at square, this is a given equation asking dimensionally it is correct or not. How can we understand? For example, this is S stands displacement, dimension formula of displacement is L. Next here ut, second physical quantity is ut, dimension formula of ut is LT inverse, dimensional formula of T is what? T. So LT inverse into T is what? L. So then dimensional formula of ut is L, dimensional formula of S is L. So then what is dimensional formula of half at square? So half, there is no dimensional formula for half. A dimensional formula is LT power minus 2. Dimensional formula of T square is T square. So T power minus 2 into T power plus 2 is cancel, then you get L. That means dimensional formula of half at square L, dimensional formula of ut is L, dimensional formula of S is L. That's why this is dimensionally correct equation. This is a procedure. If we given any equation, so here in this way you have to simplify, then that is dimensionally correct or not is understood. For example, this is time period equation. Time period T is equal to 2 pi into under root of L by Z. This is dimensionally correct or not? How can we understood? Here one expression is, so here in the equation T equal to this. That means dimensional formula of T and dimensional formula of 2 pi into under root of L by Z is same. That is dimensionally correct. Suppose T stands time period. Time period nothing but time. That's why dimensional formula of T is what? Dimensional formula of capital T is T. Next, what is dimensional formula of? So here dimensional formula of 2 pi into under root of L by Z. L stands here, 2 pi is constant, there is no dimensional formula, right? 1. Next, into dimensional formula of L, L stands length, that's why write L. Small g stands acceleration due to gravity. It is nothing but acceleration. We know the dimensional formula of acceleration. What is dimensional formula of acceleration? LT inverse square. So then LL cancel. So then you get here T power minus 2 is shifting into numerator T power plus 2. That means under root T square. Square root cancel, finally you get T. Okay, now, so the dimensional formula of 2 pi into under root of L by Z is T. Dimensional formula of T is T. That means these two are similar. Dimensional formula of LHS and RHS is similar. Then what you understood? It obeys the principle of homogeneity. Then understood this equation also dimensionally correct. This is a procedure to understood the given equation is dimensionally correct or not. This is called to check the correctness of the given equation. How to understand? By applications of dimensions. That's why this is the application of dimensional analysis. Now we are going to discuss the second application. What is the second application here? That is to derive the relation among the physical quantities. Okay, now, so to derive the relation among the physical quantities, this is a topic here. So here it is also I want to explain with one example. From the example very easily understand how to construct the relation among different physical quantities. For example, this is one example. Listen to me. If force F, length L, time T are chosen as fundamental quantities, then dimension formula mass. Okay, now here actually in generally mass, length, time are considered as fundamental quantities, but here we have to in the question F, L, T are considered as a fundamental quantities, then what is the dimension formula of mass is asking. So that means here from the given question mass equation depending upon force, length, time. Okay, but how many forces, how many lengths, how many times, we don't know. So these how many indicates the dimensions, that is only understood by application of dimensional formulas. That's why by application of dimensions, so dimensional formulas in the equation, finally you get how many forces, how many lengths, and how many times. That's the procedure to construct the relation among these different quantities. That's why from the question understood mass equation depending upon these three factors. So that's why write the mass equation. M is equal, here mass M is equal to, from the question understood F power A, how many we don't know, then I consider the dimensions of force is A. I want to find out the value A. If you know A value, then understood how many forces. And in the same way, how many lengths we don't know, I consider B. In the same way, how many times we don't know, I consider C. Now we have to measure A, B, C value, substitute in the formula, you get the dimensional formula of mass in terms of these three. Okay, just measure these A, B, C. How to measure A, B, C? Suppose here it is dimensionally correct equation. The dimensional formula of left LHS and dimensional formula of RHS is similar, because here when we have to use this equate symbol based on the principle of homogeneity, the dimensions of LHS term and dimensions of RHS term is similar. That's why we have to equate. Suppose here M is the mass, we know the dimension formula of mass. What is the dimension formula of mass is M. Okay, now there is no length here, there is no times. That's why what is dimensional formula of mass? M power 1, L power 0, T power 0 is equal. What is dimension formula of force here? Force dimensional formula is what? M L T power minus 2 is the dimension formula of force. Then write it all power A. In the same way, dimension formula of length is L. So then write here L power B. In the same way, dimension formula of T is what here? T power C. This is common. So write as it is, length time is same. So now simplify. ML T power minus 2 whole power A means M power A, L power A and T power minus 2A. If you simplify it, then you get like this. Then here you get L power B into T power C. This is a procedure. Okay, now simplify again. This is M power, only we have A, there is no M values. L power A, here L power B, that means L power A plus B. Next T power here minus 2A, here C, that means minus 2A plus C. This is similar to what? M power 1 and L power 0 and T power 0. So this is it. Now it is dimensionally correct equation. So then these dimensions are similar. That means A is similar to 1 and A plus B is similar to 0. In the same way, minus 2A plus C is equal 0, because it is dimensionally correct equation. So that's why equate the dimensions. You get 3 equations. By solving these 3 equations, you get A, B, C values. That is substitute in this equation. You get the dimension formula of mass. Now we are equate these dimensions. The first equation here, A is equal to, we have 1. This is first equation. In the same way, second one is A plus B is equal to, here in this equation 0. This is equation 2. In the same way, third equation minus 2A plus C is equal to also 0. These are the 3 equations. By solving these 3 equations, you get. So from this equation you get A value. We need B and C values. From this equation, B write as a subject. So this A shifting into left side, you get minus C. Okay, already we know A value, substitute in the formula. B is equal to, what is the expression here? Minus 1. A is equal to substitute 1. Then B is equal what? Minus 1. A is equal plus 1. And if you need C value, substitute in the equation where A is equal to 1, minus 2 into 1 plus C is equal to 0. So implies here C is equal to this minus 2 into 1 minus 2 plus C, that means C is equal to 2. This is C value is 2. Now what is the dimension formula of mass here? So M is equal to, in the same way, A is equal to, we have 1. So that means F power 1 and L power B stands minus 1 here. What is B value here? Minus 1. So whereas T power what? C is equal to. So this is a dimensional formula for mass. Dimensional formula of mass is M power 1, L power minus 1, T power 2. So this is a procedure to construct the dimensional formula. Okay, is it clear? Actually this is original procedure. We have very shortcut method also we have here. What is shortcut here? Actually we know the dimensional formula force. According to the dimensional formula force, F is equal to ml T power minus 2. This is the dimensional formula. We need the dimensional formula of mass. Okay, so write as a subject M. So then you get F by this, what is remaining, LT inverse square is shifting into left side, you get LT power minus 2. If you simplify, this is F into L power minus 1, this T power minus 2 is shifting into numerator plus 2. That means what is the dimensional formula of mass? F L power minus 1 T power 2. So that means F power 1 L power minus 1 T power 2. This is similar. That means what is the dimensional formula of mass in terms of force, length and time? This is the formula. This is very shortcut for this analysis. If you know this procedure, you have to follow. No problem. Okay, but here this is always not applicable, this shortcut. Only some actually this original procedure is applicable for any question. So that's why we have to follow the original method, is very easy. We have to apply original procedure. In case it is applicable shortcut, so you have to apply. Otherwise, we have to follow the original method. Now we are going to discuss about the third application. What is the third application here? To convert one system of units into another system of units. If you know the CGS unit, but we need SI unit, that is also possible to conversion from CGS into SI or SI into CGS by using dimensional analysis very easily. Okay, so now we are going to discuss that. That is also I want to explain with one example. Here we have to follow one formula for this application. The formula is here. N1 U1 is equal to N2 U2 is the formula. What is the formula? N1 U1 is equal to N2 U2. Here N1 N2 stands the numerical values here. N1 is a numerical value in one system, first system. U1 is a unit in the first unit, or it is a dimensional formula in the first unit. Instead of unit, write the dimensional formula. There is no problem. Units also conversion by using the dimensional formula. That's why instead of unit to substitute the dimensional formula, there is no problem. Why? Because here by application of dimensional analysis, that's why instead of this unit substitute the dimensional formula, you get the one system of unit into another system of unit. Here N2 stands numerical value in the second system, U2 stands unit in the second system. This unit also we have to substitute in terms of dimensional formula. So then very easily you get it. So I want to explain one example. Okay, what is the example? So for example, already we have discussed in the previous topic, 1 Newton is always similar to 10 power 5 dynes, but you don't know 10 power 5 dynes. So 1 Newton how many dynes is the question. Okay, you don't know 10 power 5. So by using this dimension analysis, it is possible to convert. Not only this 1 joule is equal to 10 power 7 ergs. That's also we have to possible to conversion from one system to another system by using dimension analysis. Okay, and it is possible by application of this formula, you get it. Here Newton is SI unit, dyne is CGS unit. That means here SI unit is conversion into CGS unit. So Newton and dyne are the units of force. Okay, that means here just the unit is Newton, SI unit is conversion into CGS unit. That's the concept. Here this Newton and dyne is a force. That's why we have to use the force dimensional formula. Before this procedure, first we need to remind the dimensional formula of force. What is the dimensional formula of force? According to the dimensional force, ml T power minus 2. Okay, now substitute in the formula. Actual formula is N1 U1 is equal to N2 U2. we need n2 value here. Suppose this is, you have to consider this is n1, this is u1, this is n2, this is what, this is u2. Substitute these all values from this equation. Suppose actual formula is what, n1 u1 is equal n2 u2 is the formula. So then here write like this, n1 by this n2 is shifting it to left side, n1 by n2 is equal, this u1 is shifting, then you get u2 by u1. This is a procedure. Next, what is n1 and n2 values? n1 is a numerical value in the first system. First system is SI system. n2 is a numerical value in the second system, means in the CGS system. Okay, we don't know this value, we have to find out this value. u1 is a unit in the first system, u2 is a unit in the second system. Okay, substitute these all. So n1 is a known value in SI system. Numerical value is 1 Newton, means what, here numerical value is 1, that is a known value. That's why instead of n1 substitute 1. We don't know n2 here, we have to find out, that's why n2 write as it is. It is similar to u2. u2 stands unit in the unit of unit in the second system. Second system is CGS. So that means this unit is right in terms of dimensional form. What is dimensional formula of force here? Dyne is the unit of force. Force dimensional formula is what, mLT power minus 2. But it is this unit in the second system. Second system, the quantities are represented by here m2, l2, t2. Okay, in the same way write u1. u1 is a unit in the first system. First system, the units also write in terms of dimensional formula, that is m1 l1 t1 power minus 2. This is a procedure to apply and these dimensional formulas. Now simplify this equation, you get the n2 value. How to simplify? So listen carefully, this is 1 by n2 is equal, so here m2 by m1 write at one place. Okay, because both are represents the masses, whereas L1 L2 is indicates length, that's why write at one place, that is L2 by L1. Next, whereas T1 T2 stands times, that's why write T2 by T1 whole power minus 2. Now simplify this equation. How can it simplify? So m2 stands mass, m2 stands mass in CGS system, in second system, in CGS system. Okay, now that's why we know the units of mass in CGS. What is the units of mass in CGS? That is gram is a CGS unit. So that's why instead of m2 write gram. m1 is a unit of mass in SI system. First system means SI. In SI system mass unit is kilogram. That's why instead of m1 write kilogram, instead of m2 write gram. Next, whereas L2 stands unit of length in CGS system. Second system means in CGS system the unit is centimeter. So L1 is a unit of length in SI system, that is meter. So whereas unit of time in second system, first system is same, that's why just here write second whole power minus 2. Again simplify this. How can it is possible to simplify? Here gram write as it is. Suppose kilogram is write in terms of gram, otherwise this gram is write in terms of kilogram, no problem, anything which is possible, right? So 1 kilogram is equal to 1000 grams is the relation. 1 kilogram is equal to 1000 grams. Next, here centimeter by meter, 1 meter is equal to 100 centimeter. In this way we have to simplify. S by S means they are cancelled. 1 power minus 2 is what, 1. That's why instead of 1 power minus 2 is 1. Now simplify. Gram cancel, centimeter cancel. What is the value? 1 by 1000. 1 by 1000 means 1000 stands 10 power 3, whereas 1 by 100 stands 10 square. So it is similar to 1 by 10 power 5. 10 power 3 into 10 power 2 is 10 power 5. This is similar to 1 by n2. But we need n2 value by cross multiplication. n2 into 1 n2. Then 10 power 5 into 1 is 10 power 5. Then what is n2 value? 10 power 5. This is a procedure to measure the n2 value. That means now onwards what you understood, 1 Newton is equal to 10 power 5 times. This is a procedure. Okay, now why I explain this? Actually, you know 1 Newton is equal to how many times is this question is given in the exam. You have to attempt it directly. Don't write this solution here actually. But if given any different quantity, so you don't know the relation between any two units, we have to follow this original method. If given 1 Newton is equal how many days? Substitute directly. 1 joule is called how many ergs? 10 power 7. But instead of this, in the same question is given in terms of another any units. So this is a original method. By application of original method you get it. Otherwise given the same question you have to attempt it directly. That's why I want to explain this original procedure also. Now we are going to discuss about the limitations of dimensional analysis. Okay, what are the demerits or limitations of dimensional analysis? So actually we have so many applications, but we have some limitations, some situations they cannot be applicable. That's why we have to understand what are the limitations of dimensional analysis. The first limitation is, listen carefully, that is proportionality constants cannot be determined by dimensional analysis. Okay, now if you want the dimensional formula of the proportionality constant is, it cannot be applicable. That's the limitation of the dimensional analysis. If given a proportionality constant and asking derive the dimensional formula, so it is not possible to derive. That is one of the limitation. And one more important limitation, this is very important here. What is the point? Formula consisting of trigonometric functions like sine, cos, tan, etc. or logarithmic functions such as log, or exponential function, that means such as e power x, then cannot be derived. Okay, now so it cannot be applicable if the given equation is consisting of trigonometrical functions or logarithmic functions, exponential functions, so then it cannot be derivated. That is one of the limitation. That means if given these functions, that function they have not dimensions, because here that is one of the limitation. If they have not dimensions, we have to consider that is dimensionless quantity. If given any in the equation sine function is given, its dimension, there is no dimension, that means we have to consider dimensionless quantity. That means its dimensions are m power 0, l power 0, t power 0. In this way we have to consider, if given in the equation any trigonometrical function or logarithmic function or exponential function, you have to understand in this way. This is one limitation. And one more limitation is, by application of dimensional analysis, it is not possible to differentiate between scalar quantities and vector quantity. The given physical quantity is scalar quantity or vector quantity, cannot distinguish by application of dimensional analysis. That's the limitation. By application of dimensional formula, here not understood it is a scalar quantity or a vector quantity. That's the limitation. Next, one more limitation is, so formula which contains 2 or more terms in the RHS cannot be derived. In the given equation, so in the right side 2 or more quantities, so then by application of dimensional analysis, it cannot possible to derive the relationship here. So in the right side 2 or more quantities, so then it cannot be applicable. That is one of the limitation. One more limitation here, formula contains dimensional constants cannot be derived. If the given equation consisting of any dimensional constant, but for these equations it cannot be applicable. There is no possible derivative that equation if the equation consisting of any dimensional constants. So these all are the applications. So here one more limitation also, that is, actually it is very difficult to apply the dimensional methods when the physical quantity depending upon more than 3 fundamental quantities. More than fundamental quantities, mass, length, time. If it is depending upon more than these 3 fundamental quantities, it is very difficult to applicable. These all are the limitations of dimensional analysis. In the next video, we will discuss about the previous ECET exam questions. Must should watch that video. Okay. Thank you. Have a nice day. Bye. I love you.